A very good morning to our lecturer, Sir Tang Heng Kwong, and to all our fellow friends. Today, we're gonna present about our project design of steel design. My name is Arnold Dorothy Tepin, and my matrix number is 05DKA22F1026. So next, we move to the wall 1 calculation. So for wall 1, the formula is 1.35 GK plus 1.5 QK. And for GK, we got it from YW times T times H, and we get 1.18 kilonewton per meter. So for the QK for wall 1 is 0, and wall 1 is equal to 1.35 times 1.18 kilonewton per meter plus 1.5 times 0. So we get for W1 is 1.59 kilonewton per meter. So next we calculate the shear force. For the shear force, WL divided by 2. So we get 5.57 kilonewton per meter. And the UB we use is 356 times 171 times 67 for the UB size. And we get 0.8 below than 1, and it's okay. And for the bending moment is equal WL power of 2 divided by 8, and we get 9.74 kilonewton per meter. So therefore you see, we use the size 263 times 203 and 60. So the answer is 0.81 below than 1. So it's okay. For the UB size and UC size, we get it from the Eurocode.
Good morning to Sir Tang. My name is Ferdinand Anagat. Today I would like to present about steel design for wall 2. As you can see on the SketchUp, wall 2 is the middle or center between wall 1. For the calculation for wall 2 is, firstly the formula is 1.35 GK plus 1.5 QK. Firstly, we need to find the GK first. The formula for GK is YW multiplied by T multiplied by H, and the total for GK is 2.83 kilonewton over meters. And then we need to calculate for the wall 2 by using the first formula after we get the GK. And then the total load for wall 2 is 3.82 kilonewton over meters. For the shear force, the formula for shear force is WL over 2, and then we got 13.37 kilonewtons over meter. And then for the bending moment, the formula for bending moment is WL square over 8, and the total of bending moment is 23.39 kilonewton over meters. As you can see here, the UB and UC is the size of the beam and the column, and it is taken from the Eurocode by referring to factor of safety.
My name is Haninilina Sofia bint Hamza, and my matrix number is 05 DKA22F1062. The wall that I'm going to present is wall 3. So for GK slab, the formula is SW plus F times LS over 2. So we just put the number, which is 2.36 plus 1.5 times 7 over 2, and then we get 13.51 kilonewton per meter squared. For QK slab, the formula is QK times LS over 2, and then we put the number, which are 3 times 7 over 2, and then we get 10.5 kilonewton per meter squared. Next is GK wall. The formula are YW times T times H, and then we put the number and we get 288 kilogram per meter. And then we switch the unit to kilonewton, and then we get 2.83 kilonewton per meter. For W3 wall calculation, we use the formula that was used earlier in wall 1 and wall 2, which is 1.35 GK plus 1.5 QK. And then we put the number in the formula, the number that we calculated in the formula, and then we get 37.81 kilonewton per meter. The UB that we use is 457 times 191 times 106, and then we get 0.81, which is lesser than 1, which is okay. Next is UC. We use 254 times 254 times 89, and then we get 0.85, which is lesser than 1, which is also okay. Thank you.
Very good morning to our lecturer Sir Tang Hing Kwong. My name is Timothy Thomas. So today we would like to present about a steel design and about our project design. So my matrix number is 05 DKA 1007. So for my calculation, I choose a wall 4. So the formula for GK slab is SW plus F times LS over 2. So just put the amount that you get. For example, SW 2.35 plus 1.5 times 7 over 2, and then the amount that I get is 13.51 kilonewton. And then second is QK slab also. The QK times LS over 2. So the QK, the amount is we choose from our matrix number. So as my matrix number is 1007, so I take a 0.5. So 0.5 times 0 times 7 over 2, I get 26 over 26.25 kilonewton. Next, for the GK wall formula is density times thickness times height. So the density that we choose for our wall is 800 times the thickness is 0.1 and the height of 3.6 meters. So after do some calculation, we get 2.83 kilonewton meter. And after that we need to use the formula 1.35 GK times 1.5 QK. So the GK you get, you need to put inside the formula, and the QK also inside the formula. After that you will get 61.43 kilonewton meter. After you get that amount, you go to Eurocode and just put the amount in the Eurocode, and then you will get the UB of the beam size. I choose is 533 times 210 times 138. So I get 0.96. It's less than 1.0, so it's mean okay. Next, for you see the size is 254 times 254 times 149, and the amount that I get is 0.83, less than 1. It's also okay. So this is our SketchUp. As you see, the W4 is in the middle, between W3 and W1. In the middle part, that is W4. And also, don't forget about the easy beam. You need to use easy beam to find the MY and VY also, to you put in the Eurocode. So that's all.